So we've learned about horizontal and vertical transformations, and we've learned about vertical and horizontal stretching and compression. Now we're going to learn about what causes reflections about the x and y axes. And for this, I've thought it easiest to explain by taking an example. Y is equal to the square root of x, or we can think about this as f of x is equal to the square root of x. So let me draw a graph of it first, and this will be more simple to explain this way. So if we have 0, we have 0. If we put in 1, we get the square root of 1 is 1. And if we put in 4, we get the square root of 4 is 2. That's here. This is what the graph looks like. And in this section, we're going to talk about reflection, about the x-axis and about the y-axis. So let's start with the x-axis. So reflection about the x-axis would mean that I want this graph to be down here, like this. So if I want to reflect it about the x-axis, and I look at my equation, how would I go about doing that? So how would I manipulate this so it would look like this? So let's first look at what the difference is. Here we see the x's are the same, so it's most likely not going to be anything to do with manipulating the x. What is different is that the y values are negative. They're the same, but negative. So here it would be 1 minus 1 instead of 1, 1, and here it would be 4 minus 2 instead of 4, 2. But how are we going to get a negative value from a square root? Well, what we would have to do is multiply it by a minus after, and that is what causes a reflection. So a reflection would be f of x times minus x squared. Actually, that's a little bit hard to see in blue, but that's what this would be. So in order to reflect about the x-axis, let's write it in general form. So if we have some function y is equal to f of x, in order to reflect it about the x-axis, all we have to do is multiply the function by a minus sign. So let's pick a different example really quick. So let's suppose we have y is equal to x squared. I didn't mean to do that. So let's put a graph on here real quick and say, here's our graph. Goes 0, 0, 1, 1, 2, 4, 0, 0, 1, minus 1, 1, minus 2, 4. So here's our graph. So now that we know the basic idea of a reflection about the x-axis, we want this thing to be pointing downwards instead. So how would we go about doing that? All of these values are going to be the same, except they're going to be minus 1, 1. Or they're going to be minus 1, minus 1. Yeah, that's what I meant. Minus 1, minus 1, and they're going to be 1, minus 1, and 2, instead of 4, they're going to be 2, minus 4. So how would we go about doing that? Well, what we would do is just put a minus sign in front. So y is equal to minus x squared. And that goes by this form, this same sort of general form, where y is equal to the negative f of x. So these are how reflections about the x-axis go about. So let's graph this. So if we wanted to reflect it, we put the minus sign in front of our function, of our base function. And that causes the y. So we still have a positive x. We put in 1. We get 1 squared. But then we have 1 times minus 1, which is 1. And when we put in 2, we get 2 squared, which is 4. And then times minus. 1, and then times a minus. So that makes it 2 minus 4. Oh, I forgot that, but yeah, 2 minus 4. And we get the same things for the negative values because it's symmetrical. So this is minus x squared, and this is x squared. So that's how reflection about this looks like a chromosome. But anyways, this is how reflection about the x-axis looks like. So now let's talk about reflection about the y-axis. And for this, I'm going to go back to our first example, y is equal to the square root of x, or f of x is equal to the square root of x. So let's put the graph up. And again, let's put the base function up real quick. So reflection about this y-axis would happen if this was pointed the other way, like this. So let me draw what it would look like reflected about the y-axis. It would be minus 1, 1, and then 2, minus 4, 2. And you might say, well, how is that possible that we're putting in minus x's and getting real answers? Well, the only way we can do this is by putting a minus sign underneath the radical. So we would get y is equal to the square root of minus x. And it might look a little bit strange because we're having a minus x under a radical, and you might be like, well, I thought we couldn't have minus signs in the radical. Well, that's correct. If we put in positive numbers for here, so if we put in 1, 2, 3, we're going to get minus the square root of 1, minus the square root of 2, minus the square root of 3, which all are not real answers. However, if we put in, let me do it in a different color. However, if we put in minus 1, minus 2, minus 3 for this one, we're going to get a minus, which is plus 1. The square root of positive 1, which is a real number. We're going to get the square, if we put in minus 2, we're going to get minus 2, which is 2, square root of 2, which is also a real number. And so on, for minus 3, minus 4, and forever and ever. So here we're having essentially what we're doing is we're replacing x with minus x. So this is how a reflection about the y-axis would look like in a general form. So we have y is equal to f of minus x. So in all of these sort of horizontal shifts and compressions, what ends up happening is that we're replacing the x values. So instead of x, we're plugging in minus x for our values. And every time we've had a vertical manipulation, it's been the function that's been multiplied by some constant, or it's being added to, or it's being multiplied by a minus. So that's how you tell the difference generally between horizontal shifts and vertical shifts. Here we're replacing x's. So this is what is going to cause it to be a reflection about the y-axis. So this is I know it's a reflection about the y-axis. When you think of y-axis, you think vertical, but when you're reflecting across the y-axis, it's almost shifting like in a horizontal manner. It's being reflected horizontally though. And here above, this is being reflected vertically. So even though we talk about it even though we say it as reflection about the x-axis here, and we think horizontal for x-axis, when you're reflecting it about the x-axis, you're actually reflecting it in a vertical direction. And here when we say reflection about the y-axis, when the y-axis is vertical, but when you reflect across it, it's a horizontal reflection. So that's all there is to know for reflections. So let's talk about it real quick again. When we have y is equal to minus some function, so a negative times a function, outside. So this is very much like our compression, except this is a minus. This is going to be a reflection of the x-axis. So that means here's our x-axis. That means it's going to be, even though we're talking about it being reflected across the x-axis and we think horizontal x-axis, there's actually a vertical reflection. So remember about things being multiplied by the function are generally going to be some kind of vertical change. If something's being added to it, if something's being multiplied to it, if a number's being multiplied to it, it's going to be a vertical shift, it's going to be a vertical compression or stretching, or it's going to be a reflection vertically. And when we have y is equal to f of minus x, where we are replacing, so this we replace in our function x with minus x, this is going to be a reflection of the y-axis. And again, so here's our y-axis. Although we think of things that are vertical on the y-axis, when you reflect something across the y-axis, you're actually having a horizontal reflection. And again, it's our general sort of guidelines. When something is happening, when we're plugging in some x manipulation, whether it's a minus sign which causes a reflection, or if we're multiplying it by some number, or if we're adding some number, these are all going to be changes horizontally in some way or another. If we're adding, it's going to be shifting it. If we're multiply it by something, it's going to be compressing or stretching it. And when we are multiplying it by a minus, it is going to be a reflection.